All right, guys, so dividing polynomials here. So let's start out with a little question first. Just going back to basics, how do we know if something is a factor of something? Like, for example, is 5 a factor of 45? Right, and let's say, you didn't know what factors meant, or you didn't know what the term meant, but you kind of knew it had something to do with does 5 go in evenly or whatever. So you could say, all right, I'm going to take 45 and divide it by 5, and I know that gets me 9, so since that's a whole number, um, that means that 5 is a factor, okay? But for example, is 6 a factor? 45 divided by 6, okay, that's not going to go in evenly, right? That's going to be, what, 7.5, I believe? 42, so 3, yeah, 7 and 3/6. So since it didn't go in evenly, we know 6 is not a factor. Okay, so sometimes in order to tell if something's a factor, you have to divide the things together, especially once we start dealing with algebraic expressions and whatnot. You're not necessarily going to be able to tell just by looking at something and know if it's a factor. You're going to have to do division. So we're going to talk about how do we do that. We did here where we actually did a division problem. Let's show that x minus 3 is a factor of this big polynomial, or x cubed plus 4x squared minus 15x minus 18. And let's do it before we even talk about dividing. Let's just see, is this thing factorable using any methods that we may have come across. And to me, looking like a 4-term polynomial, the one method that kind of jumps out to try first might be the grouping method. So let's see if that works. So can we factor that guy? If we look at it again, there's no common factor in all 4 terms. But if we break it up into 2 groups, there is, I hope. So we take out an x squared, and we'd be left with x plus 4. Okay, and then with the other 2 terms, there's a minus in the middle. Now the greatest common factor of 15x and 18 is going to be 3. And we would be left with 5x minus 6. So let's see, is this thing factorable? It doesn't look like the grouping method's going to get it done. And I did just notice a little typo we had. This should be a plus 6, right? Because we already had the minus there, so the minus times the positive is going to be the minus there. So hopefully you guys caught that. But anyways, point remains, grouping method's not going to work. So I don't know if we would be able to tell this thing as a factor without doing it. How do we divide these things, right? We would need to take this large polynomial and divide it by x minus 3 and see if we get a remainder or not. Okay, so let's talk about how to division. There's a couple methods. There's long division, which I'm going to do first, okay, which is, it's long, okay? It's called long division, right? So it has its pros and cons, though, okay? The pro is that it can do any division problem, okay? It doesn't matter what type of polynomials you're dealing with. Long division will get the job done. Some people just always use it. There is a faster method that works in certain cases called synthetic division, which we will do in just a second, but it doesn't always work. Okay, so this is a method to fall back on, and sometimes has to be used. All right, so to get this started, you really want to keep yourself organized here because there's going to be quite a few little steps and whatnot. So what I would do, instead of trying to see all these terms at the same time and getting in your head and everything, focus on just that first term and then the first term under there for now, okay, to get the ball rolling. So what we're going to do, we're going to ask ourselves, how many times does 3x go into 3x cubed? Okay, or in other words, what would you multiply 3x by to make it become 3x cubed? Okay, and the answer is x squared. Okay, and I usually write it just above the next term there because what we're going to do next is we are going to take that x squared and we're going to multiply it by the 3x plus 2 on the outside. Okay, so kind of distributing it, right? So x squared times 3x plus 2. Let's write that on the side for the first one. So x squared is going to get multiplied by the 3x plus 2, right? And just remember when you do long division with numbers, that's what you do. You first get the first piece of the quotient up there, and then you would always multiply by what's out here, right? So we're doing the same thing. Okay, so x squared times 3x plus 2 is going to distribute to become 3x cubed plus 2x squared. Okay, right, we just distributed it like that. And then when you did long division with numbers, we would subtract this quantity from above, right? So let's do the same thing. Okay, so the 3x cubed minus 3x cubed cancels out. Now I have 5x squared take away 2x squared. That's going to become 3x squared. And we always bring down the next term. Okay, so it's exactly the same as when you did long division back in the day. Okay, you just got to be extra careful with these. Now we're going to keep the process going. I'm going to say how many times does that 3x on the outside go into 3x squared? Okay, so 3x times what would become 3x squared? So it needs to be another x. So we're going to do a plus x. And now I'm going to distribute that x that we just did, multiply it by the 3x plus 2. So that'll give me 3x squared plus 2x. Okay, and we will go ahead and subtract these. Again, just be very careful. The 3x squared minus 3x squared cancels out. The 8x minus 2x is 6x. And we will bring down the plus 7 that was sitting there. And now we're going to do the process one more time and say how many times does 3x go into that 6x? Okay, so 3x times what will get 6x? And it's going to be, oops, let's not highlight. It's going to be a positive 2. Okay, so we're going to multiply the 2 that we just got times the 3x plus 2. So that's going to get me 6x plus 4. And we will subtract these. So the 6x minus 6x is 0. The 7 minus 4 is 3. Okay, and we have nothing left to bring down, so what ends up happening is that 3 becomes our remainder. Okay, and we write the remainder as a fraction over the thing we divided by. So we're going to, at the end of our expression here, put a plus 3 over 3x plus 2. Okay, so this right here becomes our final answer. That's the answer to the division problem. Couple things to take away from it. It's showing basically that the 3x plus 2 is not a factor of that larger polynomial, and we know that again because its remainder was not 0. Okay, how we talked about it at the beginning of the warm-up, because we'll definitely be using that concept quite a bit here, right? Okay, if we wanted to, when we did the long division up here. Okay, now so another method for division, right? Because that one's a little messy, it's a little tricky. You do need to know it. Okay, there are going to be certain problems that require it. So just with a little practice, it gets better. It should be familiar from Algebra 2, though. So hopefully it's somewhat familiar, at least coming in. But anyway, synthetic division is another method. It's a lot quicker, a lot simpler, but it can only be used when we are dividing by a linear binomial. Okay, so we can't do it if you're dividing by a quadratic or anything other than a linear function with 2 terms in it. And it's going to work best when the leading coefficient is 1. So let's look at an example how it works and then see there is a way to kind of work around this last requirement of it. Since it's we got one. But let's say we wanted to divide this synthetically, okay? And notice the thing we are dividing by, okay, down here, is a linear binomial, right? It's x to the first power. It's mx plus b form, so it's just linear, and it does have only 2 terms, so it's binomial. So in order to do that, the trick is this. You want to take the opposite of what you see. Okay, so we're going to do a positive 3, and it kind of goes in a little box here. It's like its own little special thing. And then what we're going to do is take the coefficients from up here. We have a 1x to the third, a 4x squared, a negative 15x to the first, and then a negative 18. Okay, you need to make sure, and this is true for long division as well, make sure that we didn't skip any powers of x. Okay, it was third power, second power, first power, and then the 18 is a constant. Okay, if that happens in any division problem, you're going to want to fill in zeros as like place values. Okay, so just watch out for that. And then here's the process. Okay, so since we did the opposite of the minus 3, we're going to kind of do everything backwards from long division. Okay, we're actually going to bring down the first term, and then instead of dividing, we're going to multiply. So that 1 is going to get multiplied by the 3 in the box, and that number is going to go right here. Okay, and then instead of subtracting, which we did with long division, we are going to add these straight down. So 4 plus 3 is 7. And then we're going to repeat the process. 7 is going to get multiplied by the 3 again to become 21. Okay, we'll add the negative 15 and 21 to become 6. 6 is going to get multiplied by the 3 to become 18. We're going to get a 0 over here. This last number will always be your remainder. Okay, and the other numbers that we got, those are going to be the coefficients. Oops, I had a hiding a, oops, I don't know what's going on here. I was hiding a question, so there's a white rectangle here that you might have seen move or whatever. But anyways, the coefficients we got are these are the coefficients to the answer, okay? And the trick is this. Our original problem, our original term was a third degree, okay? So when you divide by a linear term like we did, it drops the degree 1. So we have 1 for the x squared term, 7 for the x to the first term, and 6 for the constant. Okay, that's going to be the answer to this division problem. Okay, it's the same thing we would have got if we would have done long division. It's just a much quicker, simpler method of doing that. Okay, linear by All right, so remember we did this one long division just a few minutes ago. Okay, polynomial that we are dividing by, right? The 3x plus 2. We can do a little bit of manipulation and make this thing work with synthetic. So this type of problem, I'll leave up to you guys to decide how you want to do it. Okay, we did a long division, like I said, always works. If you were going to do this with synthetic division, we need this term to become a 1. So the trick is you divide all the coefficients by 3. Every single coefficient. Okay, and you definitely get some fractions in the mix. But what it ends up turning into now is x plus 2/3 dividing into, that would become x cubed plus 5/3 x squared plus 8/3 x plus 7/3. Okay, and since we did it to every term, it's okay, right? It's kind of like doing something to both sides of the equation. We divided every single term by 3. Okay, so synthetically, we would say, all right, I'm going to take the opposite of that. I'm going to get my coefficients, 1 for the x cubed, 5/3 for the x squared, 8/3 for the x, oops, I don't need to write the plus there, and 7/3 for the constant term. And then we could just follow the same synthetic process we did before. It just gets a little messy because you will be dealing with fractions. So let's see what happens on this one. So I bring down the 1, right, and then we multiply. So 1 times negative 2/3 is negative 2/3. Okay, adding those together, so 5/3 take away 2/3 is going to be 3/3, which is really just 1. Okay, and then we'll do 1 times negative 2/3 again to get negative 2/3. Okay, the 8/3 and negative 2/3 is going to become 6/3, right? 6/3 is really 2. And then 2 times the negative 2/3 is negative 4/3. And we'll get 7/3, take away 4/3, which is 3/3. And we just get a 1 there. Okay, so cleaning this up so we can write our answer. Again, if you remember the way synthetic works, the answer is always 1 degree lower than what we started with. So we started third degree, so our answer is going to start as a second degree. And we have the coefficients right here, so we have 1x squared plus 1x plus 2. And then the remainder always goes over whatever we were dividing by. Okay, so that would be a way of writing the answer. Now, it's algebraically, sometimes we don't like to have that fraction within a fraction, and this is just an optional step here. But what I mean by that is having this fraction here. So what you might see sometimes is they'll multiply top and bottom of this last term by 3. X squared plus x plus 2. And what it does is it makes the numerator become 3. If we distribute a 3 to this bottom one, it'll become 3x plus 2. And all that's doing, again, it's just making you not have a fraction within a fraction. So I'm okay with either one of these. Algebraically, they're equivalent. But if you notice, this is the way to... Okay, so that one's kind of optional. For dividing by a linear divisor, you can decide if you want to go long division or synthetic division. And it's just a matter of, do you want to deal with the fractions now, or would you rather just mess with long division? Okay, and we will be using these methods to eventually find zeros and solve equations with polynomials. You'll first have to divide to show something as a factor, and then it's maybe either factorable after that, or we can kind of jump to the quadratic formula as well. Okay, so that's dividing polynomials.